Let us now start the mathematical analysis of the two-cavity klystron. So we will start from the leftmost part. So the first part is the electrons are being emitted by the cathode. So I'm going to start with the first part. So the velocity of the electron, right? The electron is being emitted with a certain velocity. So the velocity of the electron beam is given by V naught is equal to root of 2e V naught divided by m, where E is the charge of the electron, it is 1.6 into 10 power minus 19, m is the mass of the electron, which is 9.1 into 10 power minus 31, and V naught is the DC supply given. So when we substitute E to be 1.6 into 10 power minus 19, let this V naught remain the same, m is 9.1 into 10 power minus 31. So we are substituting the values of the charge of electron and mass of electron, and therefore we get the velocity to be 0.593 into 10 to the power of 6 into root of V naught. So this is the value of the velocity of the electron that we are giving, and we have started with the leftmost part where the electrons are being emitted. Next, when you observe in the diagram, the electrons passes through a particular space which is called as the Buncher gap. So we need to first know for what amount of time the electron stays in this particular gap, because here only because of the EMF induced, the velocity of the electrons get modified. So next part, I am going to write down the transit time of the electrons in the Buncher gap. So next we will find out what is the transit time of electrons in the Buncher gap. We will mention it as tau, and tau is given by the starting time the electron enters the gap is T0 and the ending time it leaves the Buncher gap is T1. So it is T1 minus T0. This is the time, amount of time the electron stays in the Buncher gap. And we know that time is equal to distance by velocity. So this distance of the gap is given by d. So this is going to be equal to d divided by V0. Next is the gap transit angle. The transit angle is a function of the angular velocity as well as the time that is taken. So we can write the gap transit angle theta g as it is given by omega into tau. So it is omega into tau is given by d by V0. So therefore we are getting theta g to be omega into d divided by V0. Let us have this as equation number 2 and this one as equation number 3. Now we will start with the velocity modulation process. So the electrons have reached the gap. Here an EMF is induced because of the RF input which causes the velocity modulation. So let us start with the velocity modulation process. So we are going to start with the velocity modulation of the electrons. Now we need to first of all calculate the average microwave voltage. So we're going to calculate the average microwave voltage in the Buncher gap, because in the gap only the velocity gets modulated. So average microwave voltage in Buncher gap. So we mentioned that as Vs, it is average. So it is 1 by the time it takes through the Buncher gap. So it is 1 by 2. The starting time that the electron enters the gap is T0. It comes out at a time of T1 into the input signal that we are giving into dt. So we can write this as this is equal to 1 by 2 integration of T0 to T1. V of t is nothing but the signal has an amplitude of V1 and it is an AC signal, so it will be having a sinusoidal variation. So it is V1 sine of omega t dt, where V1 sine of omega t is nothing but the RF input that we are giving, and that is the signal that has to be amplified. So let me take V1 outside because integration is with respect to time. So it is V1 by 2 integrating sine theta, it is minus cos omega t divided by omega. Lower limit is T0, upper limit is T1. Omega is once again a constant value. Let me take it outside. So it is V1 by omega 2 minus cos of omega T1, upper limit, minus, again there's a minus here, so minus of minus becomes plus the lower limit value. So cos of omega of T0. And we already know that tau is equal to T1 minus T0. So from this we can write T1 as tau plus T naught. So we will substitute this in the above equation. So first of all, let me write Vs is equal to V1 divided by omega into 2. I'll bring the positive term first and then I'll write the negative term. So it is cos omega of T naught minus cos omega of T1 is 2 plus T naught. So this will be V1 by omega into 2 cos of omega T naught minus, we will multiply this omega inside. So this becomes cos of omega 2 plus omega T naught. Fine. And we know that tau is equal to distance by velocity. Time is distance by velocity. So Vs can be written as V1 divided by, we can write it as distance by velocity into cos of omega T naught minus cos of omega d by V naught. I am substituting time is equal to distance by velocity in this equation plus omega into T naught. Now I'm going to make a basic modification to bring this of the form cos of A minus B minus cos of A plus B. For that, what I'm going to do is I'm going to write this as V1 into omega d by V naught. This first term for now I'll retain it as such. So it is cos of omega T naught minus cos of, I'm going to write this omega d by V naught, this particular term as omega d by 2 V naught plus omega d by 2 V naught. So this is total one term. I'm splitting it as half of the term plus half of the term. So omega d by 2 V naught plus omega d by 2 V naught is, it gives back this omega d by V naught. So we are making this simple modification here plus this omega T naught remains the same, right? So I'm going to modify the first term now to bring it of the form cos of A minus B. So it is V1 by omega d by V naught. I'm going to write this as cos of omega T naught plus omega d by 2 V naught minus omega d by 2 V naught. Now what happens when I add and subtract the same term? The two terms gets cancelled. We will be having only this same omega T naught. So this term, I'm writing it, I'm adding and subtracting omega d by 2 V naught minus second term is, we'll rearrange the terms. So it is omega T naught plus omega d divided by 2 V naught plus omega d by 2 V naught. Why we are doing this thing is, it is to bring of the form cos of A minus B minus cos of A plus B. This whole term is A, this is B. Again, this whole term is A and this is B. So, cos of A minus B minus cos of A plus B. The formula is 2 sin A sin B. So, the term A here is omega T naught plus omega d by 2 V naught and the term B is omega d divided by 2 V naught. So, let us substitute it in the formula 2 sin A sin B. So, Vs is going to be equal to 2 sin of A. So, divided by omega d by 2 V naught into sin of B. So, this term we have written it in the form of 2 sin A sin B. This term we have missed it out. So, let me write it at the last. So, it is V1 by omega d by V naught. Right? So, let us perform further simplification on this. Now, what is omega d divided by V naught? It is nothing but the gap transit angle, which is theta g. So, we already found that theta g is equal to omega d by V naught. So, therefore, Vs becomes V1 by theta g. This term, I am writing it first into 2 sin of omega T naught plus theta g by 2. This term becomes theta g. Again here this term becomes sin of theta g by 2. So let me take this 2 to the denominator term here. So I can write this as V1 by theta g by 2. When we reciprocate, we'll get it back as 2 sin, the same form, into sin of omega T naught plus theta g by 2 into sin of theta g by 2. So we have almost brought the equation or the formula for the average microwave voltage. So it is V1 into sin of theta g by 2 by, I'll write that term here, theta g by 2 into sine of omega t naught plus theta g by 2. This term sine theta g by 2 by theta g by 2 is called as the beam coupling coefficient, and it is represented by beta I. So I'm going to replace this as, we're going to write the equation for the microwave voltage, average microwave input voltage. V1 Vs is equal to V1 beta I sine of omega t naught plus theta g by 2, and where Bi, the beam coupling coefficient, is given by sine of theta g by 2 divided by theta g by 2. So let this be equation number 4 and let this be equation number 5. Fine. Next, to continue with this particular derivation, so this is the average voltage in the buncher gap. Now, as I told you, the electrons possess the same value of density. So therefore, the amount of energy before the gap will be equal to amount of energy after the gap. So amount of energy before gap. So before gap, it is only the potential energy because there is no change of velocity. This is equal to amount of energy after gap. So after gap, there is a change of velocity, so it has some kinetic energy because there is a possibility that electrons can either move faster or it can move slower. So the the potential energy of the electrons will be equal to the kinetic energy of the electrons, right? So the potential energy is given by E into V, and the kinetic energy is half m of V square, half mv square, and after the gap means the time is t1. And what is the total voltage at the input side? It is the sum of the DC voltage plus the source voltage. This is equal to half m of V square of t1. So from this we can find the velocity with which the electron is traveling. So from this, V square of t1 can be obtained as 2e by m. I am taking this term, we are cross multiplying the term having V square at one side into V naught plus Vs. So V square of t1 is equal to 2e, I'll take V naught commonly outside by m. So this becomes 1 plus Vs by V naught. Now take the square to the other side, it becomes square, So it is V of t1 is equal to root of 2e V naught by m into 1 plus Vs by V naught. This term root of 2e V naught by m, this is nothing but the velocity of the electron. So this can be replaced as V naught, and this term can be written as 1 plus Vs by V naught square root. So I can write it as whole power of 1 by 2. Now expanding this using the binomial equation, so we can write 1 plus x the whole power n is equal to 1 plus nx plus etc. But here it is approximately equal to 1 plus nx. So this term we can write it as V naught into 1 plus half of Vs by V naught, right? And we already found Vs in the previous part. So I'm going to write it as V naught into 1 plus 1 by 2. Vs we found out to be V1 beta I sine of omega t naught plus theta g by 2 whole divided by V naught, right? So this can be written in a proper form. So therefore, the velocity of the electron after the gap is V naught into 1 plus beta I V1 divided by 2 V naught into sine of omega t naught plus theta g by 2. So this is one form of representing the velocity of the electrons, or we can also write the velocity of electrons after the gap as V naught into 1 plus beta I V1 divided by 2 V naught sine of. So it is after I leave the gap, so I will subtract the angle from that to find the velocity. So it is either the initial time plus the angle or the time it leaves the gap minus the angle. Both will be the same. So these two equations represent the velocity of the electron. Equation 6 and 7 are the final equations. Now using this we can find the maximum velocity of the electron and the minimum velocity of the electron. So we can write Vt1 maximum as it is V0 into 1 plus beta I V1 divided by 2 V0, because the maximum value a sign term can take is 1. So when this becomes 1, this term will become V0 into 1 plus beta I V1 by 2 V0. Similarly, the minimum value the velocity of the electron can take is V0 into 1 minus beta I V1 by 2 V0. This is once again because the minimum value sine theta take is minus 1, and therefore here we get a minus sign. So these are the equations for the maximum value of the velocity the electron can take and the minimum value of velocity the electron can take. So let this be equation number 8 and equation number 9. So in the next video, let us discuss the bunching process and also calculate the efficiency of the two cavity klystron. Thank you.